Welcome back. This is Mrs. Rubright with Algebra 1, and today we are learning 1.2, solving equations by adding or subtracting. Alright guys, so our essential question, what are some different methods for solving linear equations? So we're going to focus on that today. Alright, so we are going to explore solving equations using different methods. So they have the solution set for a linear equation. They have using guess and check as a method. Guess and check to solve the solution set. So if I had x minus 5 equals 4, you could just plug in numbers. You could guess and check. So if they plugged in 10, 10 minus 5 is 5, not 4. It didn't work. They plugged in 8, 8 minus 5 is going to be 3. That's too little. So then they tried in the middle. 9, 9 minus 5 is 4. So they were able to narrow it down that the solution set is 9. That 9 minus 5 is 4. Another method for solving this equation would be to use a table to find the solution set of the equation. Okay, so they gave us the equation y plus 7 equals 10. So they tried 1. 1 plus 7 is going to be 8. 2 plus 7 is 9. 3 plus 7 is 10. 4 plus 7 is 11. And we wanted it to equal 10. So the one that equaled 10 was 3 plus 7. So their solution set is 3. And another method that they came up with was to work backwards. Okay, to work backwards to find the solution set of the equation z minus 2 equals 8. Start with the number being subtracted. Start with the number being subtracted, so I guess you're starting with the number negative 2. Work backwards, add 2, since it's the inverse of subtracting 2. So when we add 2 to both sides, we're going to get z minus 2 plus 2 equals 8 plus 2, which is 10. So z equals 10. So this is really basically what we are going to do. I just don't like doing it in this format. This is how we solve a one-step equation over to the side. So instead of subtracting 2, we're going to use the opposite operation. We want to get rid of whatever's on the same side of the variable that is not attached to it using opposite operations. So instead of minus 2, we are going to add 2, because 2 minus 2 is 0, or negative 2 plus 2 is 0. It's gone. What we did to one side of the equation, we did to the other. Bring down our z, bring down our equal sign. 8 plus 2 is 10, and we are done. So our solution set is 10. All right, could you solve each of the 3 equations above by all 3 methods? Yes. You can, yes. All problems can be solved by these methods. Hide that stuff. Okay. Two equations are equivalent equations if they have the same solution set. The 2 equations below are equivalent because they have the same solution set of 6. To solve an equation algebraically, you perform a series of inverse operations to isolate the variable on one side. When these inverse operations are completed, the other side of the equation is the solution. The addition and subtraction properties of equality can be used to justify the steps taken to solve an equation. These properties, as well as other useful properties, are listed below. So your addition property of equality. If A equals B, then A plus something equals B plus that same thing. So if you're adding the same thing to both sides, it stays equivalent. Because what you do to one side, you must do to the other. It stays balanced. Subtraction property equality. If you subtract the same thing from both sides, it stays balanced. So if A equals B, then A minus B, what? That is not accurate. So this should have been A and B. You're adding the same thing to both sides. This, you should be subtracting the same thing from both sides. This should be a C. This is a typo. A minus C equals B minus C. You're subtracting the same thing from both sides. Then it is balanced. It is equivalent. Fix that typo. The textbook publishers do not like to proofread their materials. Inverse property of addition. So any number plus its opposite is going to equal 0. Anytime you add like 3 plus negative 3, it's 0. 2 plus negative 2 is 0. Negative 2 plus 2 is 0. Any number plus its opposite, it's always going to be 0. They cancel each other out. And that is the inverse property of addition. The identity property of addition. Identity, it's going to keep its identity. What can you add to something for it to stay the same? 0. Anytime you add 0 to something, it stays the same. Just like with multiplication, our multiplicative identity is any number times 1 is going to be itself, and it's going to hold its identity. Associative property of addition. Associative. This is when you associate with someone new, right? A was friends with B and said, hey, I'm kind of sick of, B said, hey, I'm kind of sick of you, A. I'm now going to associate with C. So the parentheses changed from being B with A, now B is hanging with C, right? B dumped A for C. He's associating with someone new. Get it? Associate. Associative. It's like associating with your friends. So because it's all addition, the order doesn't matter in which you perform the addition. Okay? Since it's all straight addition, you can do it out of order because addition is commutative. You can move it around and it'll still give you the same answer. Adding or subtracting to find the solution set. Add or subtract to find the solution set. All right, so x plus 5 equals 13. So they're just saying, okay, well, we can subtract 5 from both sides, right? So they're just showing this out, and that would be the subtraction property of equality. That cancels out, and we'd have x plus 0 equals 13 minus 5. Which is really just x equals 13 minus 5. And 13 minus 5 is 8, right? So here, what's going on? What property of addition is going to be that second step? So we did 5 plus negative 5 is 0. What is that? Any number plus its opposite? Inverse property of addition. And then 13 minus 5, what are we doing there? What happened to get from here to here? Plus 0. When you're adding 0 to something, what is that? So the line that goes next to it is what happened to get there. So going from here to here, we did subtraction property of equality, right? Going from here to here, we did what? So here to here was inverse. Here to here, adding 0, identity. Solution set is 8. Y minus 11 equals 2. Y minus 11, so we're going to add 11 to both sides, right? Opposite operation to both sides. That's going to be what? When we do the opposite operation to both sides. So instead of minus 11, we're adding 11. Addition property of equality. So those cancel out to 0, right? So any number plus its opposite, inverse. Any number plus its opposite is 0. Any number plus 0. 2 plus 11, 13. Which property of equality would you use to solve x minus 47 equals 100? Explain. You're first going to add 47 to both sides, right? So addition, property of equality. So you would add 47 to both sides to isolate the x. Make sense? Okay. One more page of notes. Use properties to find the solution set. All right, so we have our original equation. They're doing the associative property. They're switching from the x plus 5 to the 5 plus 4 being in parentheses. Okay, 5 plus 4 is 9. Subtract 9 from both sides. That's the subtraction property of equality. These cancel each other out. That's the saying inverse property of addition, but it really should be, oh, I guess actually your identity is right here. So this is identity. X equals 16 minus 9. And then 16 minus 9. And there you go. Solve x plus 5 plus 4 equals 16 by first subtracting 4 and then subtracting 5. Show your work and justify each step. X plus 5. 16 minus 4. 12. Subtract 5 from both sides. X equals 7. Your solution set is 7. So right here, this is the subtraction property of equality, which you can say POE. Here, subtraction property of equality. And then here is just simplify. Which you don't really have to write simplify because I kind of did it without showing my work, but whatever. I just did subtraction, subtraction. So we're good. Does performing the steps in a different order affect the solution of the equation? Compare the steps in the example with the steps for the question above. How do the two methods differ? All right, so above, they did the, they subtracted 4 and then subtracted 5, right? They subtracted the 4. No, they didn't. They did not. What did they do? They added those first. Because addition is commutative, so it's not going to make a difference. So they added these first, and then they subtracted it, which is fine, because they combine like terms on the same side, which is totally allowed. So the first problem combined like terms first. The second problem subtracted the constants from both sides separately. They both follow the rules and therefore yield the same answer. That is everything on our notes on 1.2. So now you guys are going to begin your homework, which is on page 16 and page 17, or 16 through 18, okay? Page 16 through 18.